Next unit is on triangles, and first thing we want to do in triangles, or when we talk about a triangle, is being able to describe it or give it a name. And we give two different names to triangles. We give them a name based on their sides. All right. If there are no sides that are equal or no sides that are congruent, we call it a scalene triangle. If we have two congruent sides, all right, then we're going to have an isosceles triangle. And of course, if there's two congruent sides, what does that mean? It means there's going to be two congruent angles. Right? If there are two congruent sides, there will be two congruent angles. And of course, equilateral triangle is when all of the sides are congruent, or all the sides have equal measures. And of course, that implies that all of the angles will be congruent. And we'll talk about that in a minute. And we also classify triangles, or give them names based on the measurement of their angles. And we have a right triangle is one that has one 90-degree angle. 90-degree angle is a right angle. So a right triangle will be a triangle that has one right angle. An acute triangle. An acute triangle is a triangle in which all of the angles have measurements that are less than 90 degrees. All three of them. An obtuse triangle is a triangle where one angle is larger than 90 degrees. All right, it's an obtuse angle. So you have an obtuse triangle if you have one obtuse angle. And it's actually impossible to have two right angles in a triangle, and it's impossible to have two obtuse angles in a triangle. It is required that to be an acute triangle, all of the angles must be less than 90 degrees. And thinking back to equilateral, we said if it's equilateral, it had all the angles that were congruent, and therefore we give that a name. We call it an equiangular. Equiangular triangle is a triangle where all the angles are congruent, where all the angles are congruent. And of course, if all of them are congruent, all right, we're going to see in a minute that they each have to be 60 degrees, and if they're each 60 degrees, then it is an acute triangle. So equilateral triangles are also acute triangles. And as I just hinted at a minute ago, all right, every single triangle has 180 degrees as the sum of the measures of that triangle. There's a total of 180 degrees in every triangle. So if I have one angle that's 34 and one angle that's 98, and I'm trying to find this missing angle right down here, then I could set that equal to 180 and then subtract 34 from 180 and subtract 98 from 180, I would find that the length of this missing, or the measure of this missing angle, is 48 degrees. And some of the problems that you might be expected to do might have be set up something like this. In this first problem, we know that the sum of these three angles is 180. So if I take 35 plus 2x plus 3 plus 52, that has to equal to 180. So I gather my 35, my 3, and my 52. That equals 90. Then subtract 90 from both sides, then divide both sides by 2, and I find that the x value is 45. If I actually wanted to figure out what this angle is, I would do 2 times 45, which is 90, plus 3, which is 93. So the measurement of this angle is 93, and 93 plus 35 plus 52 equals 180. In this second example, all right, if these two sides are equal, then these two angles would have to be equal. And if these two angles are equal, they're both 75, and this is x, so x plus 75 has to equal 180. Gather my two 75s together. X plus 150 is 180. subtract 150 from both sides, and x equals 30. And what I'd like you to do is in your post that you send after you've watched the video, I would like you to answer these two questions. Find the value of x for these two questions. For this type of problem, here we're dealing with the sides, and in this case I have an isosceles triangle. Two sides are congruent, and if these two sides are congruent, then 4x minus 2 equals 18. And so I set up that equation, 4x minus 2 equals 18, added 2 to both sides, divided both sides by 4, and I got x equals 5. And of course I would like you now to find the answer to this question and put it as a post, put it included in your post for this video. Another thing we look at when we're looking at triangles is we look at the comparisons of their angles and the comparisons of their sides. And one thing that is always true is that the largest angle and the largest side are always opposite each other. The largest angle and the longest side are always opposite each other. And similarly, the smallest angle and the shortest side are always opposite one another. And the opposite of each other means that it is opposite it in the triangle. So if this is my triangle, this angle and this side are opposites of each other. And so we could actually put these sides in order from smallest to greatest. The smallest side would be opposite the smallest angle. The smallest angle is angle A, and so the shortest side will be BC. And BC is smaller than, and the next smallest side would be opposite this 46-degree angle, because 42 is the smallest angle, 46 is the next smallest angle, so opposite the 46-degree angle is side AC, so BC is less than AC, and both of them are smaller than the third side, which is the largest side, which is opposite the largest angle, which in this case would be AB. And guess what? I want you to do this last one here. Do it just like I've done it right here, except you'll be finding the measurement of the smallest angle to the largest angle.